So on to the new stuff. Moles of compounds. So chemical formula. Okay, H2O. You know what H2O stands for? Water. In water, we have 2 H's and 1 O. So the chemical formula of anything tells us the number and types of atoms in that compound. So Freon, and realize this should be written like this. I should have corrected that somewhere in translation. It got lost here. So these should be little 2's. Okay. But in this formula, we have 1 carbon, 2 chlorines, and 2 fluorines. We could also write this as a ratio. We could say the ratio is 1 carbon to 2 chlorines to 2 fluorines. We could write this as a mole ratio. Okay, we could say in 1 mole of Freon, you have 1 mole of carbon, 2 moles of chlorine, and we could say we have 2 moles of fluorine. You can write mole ratios as a fraction, and that's how we use them in our dimensional analysis as our conversion factors. We could say we have 1 mole of carbon to 2 moles of chlorine. We could reverse that and say we have 1 mole of chlorine to, 2 moles of chlorine to 1 mole of carbon. We could say we have 1 mole of carbon to 2 moles of fluorine. We could reverse that. We could say we have 2 moles of fluorine to 2 moles of fluorine, and then that could be reduced, right, to 1 to 1. And we can flip that. So all these ratios can be written. They can all be reversed. However they need to be used. The important thing is that we can write mole-to-mole ratios of a compound with elements within a compound, and that will be used in these next few problems. So how many moles of fluorine atoms are there in moles of Freon? So if there are 5.5 moles of this whole thing, in 1 mole of that whole thing, there are 2 moles of Freon, or fluorine, excuse me. So we're basically going to double it. So it's 11 moles of fluorine. Okay, so you see how that works? You can kind of do it in your head, but you could also write it out so that it's more apparent and you can use it in other problems. How many moles of carbon are there in this little guy, in C6H12O6? So in 3.50 moles of this stuff, how many moles of carbon in there? Well, in 1 mole of this stuff. Now, do you guys notice the abbreviation for mole I'm using? I'm using MOL. I don't know why that's the abbreviation, but that is the abbreviation. So in 1 mole of the stuff, there's 6 moles of carbon. So it's 3.5 times 6. Just double checking now on my calculator, that's 21. So for significant figures here, that's 21.0 moles of carbon.